Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
And in studio with us we have George, and if somebody needed to contact us, what would they need to do?
For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@curran.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Do you have all of that social media stuff?
No.
Neither do I. I don't have any of that stuff. But you know what? Do the Math does, because we need to let everybody know about the show. And we need to let everybody know about you. So where do you go to school and what grade are you in?
I go to school at Stockdale Elementary, and I am in 4th grade.
How's 4th grade going?
Good.
Yeah? You like the longer day? Because you have to go to school longer now, right?
Yep.
You like that longer day?
Yeah, a little.
Yeah, well, you know what? I'd be the same way. I'd be like, yeah, I guess I got to do it. But, you know, if we can make it a little shorter, I'd be cool with that too, huh?
Yeah.
All right. So what kinds of things are great about 4th grade? Are you able to do anything now in 4th grade that you weren't able to do in 3rd grade as far as school activities and participating in things?
Yeah, there's a lot more things, like Battle of the Books, oral language, and for 5th grade and 6th grade, there's after-school sports.
Okay, so after-school sports, and then Battle of the Books, and you said oral language, and I know that the county office is involved with that. Have you participated in any of these things yet, or are you thinking about them?
I'm only in Battle of the Books because I can't do after-school sports, and oral language, I don't want to do a solo. I want to do a duo or a verse choir, but there's
well, Battle of the Books, so you get a list of books, and you guys need to read these books, and then what happens at the end of that?
At the end, we go on a field trip to the Bakersfield Museum. Then there's 7 different stations. You have teams with random people, and then they ask you questions.
Oh, okay, so about the stories that you've read.
Yes.
Oh, good, so you're looking forward to that.
Yeah.
All right, good. Well, all the best to you on that. Have you ever heard of holiday lights?
Yes, at ComZoo.
At ComZoo, that's exactly what we were going to go to. So let's learn a little bit more about Holiday Lights at Com.
Holiday Lights at Com is back. Drive through this 3 million light extravaganza from the comfort of your car, all brought to you by Dignity Health. Enjoy countless colorful displays for the whole family.
All right, there we go. So there's the pertinent information for you. If you would like to win a pass for your entire family, your carload, all you have to do is give us a call today or next week. So this ends next week. Next Tuesday and Wednesday are the final 2 days that you can call in and receive a free pass for a vehicle full of your family members or friends or whoever you'd like to bring to go to the Holiday Lights at Com, courtesy of Do the Math. That's not a bad deal, huh?
Nope.
Were you able to go last year when you drove through it?
Yeah.
Did you like that?
Yes, it was fun.
It was fun. I did it last year too. It was pretty fun. It was pretty neat to do it a little differently. Have you ever done the one where you walk through the zoo?
No.
Okay, so the only one you know is the drive-through one.
Yes.
Well, we've done the one where you walk through. That's beautiful also, but it was a little different. It was kind of fun doing the drive-through last year, and that's what you can do this year. Do you know how you can get a free ticket to that?
Call us today.
There you go. Wanted to make sure you pay attention, young man. You were, all right? So next week, you could call in, and you go, hey, this is George. I was on the show last week. And I go, hey, George, what's going on? You got a lot of homework? And you're like, yeah, I got a little bit, but I got this one math problem I just want to check out. We do it. You win yourself a free pass for your family to go to Holiday Lights at College. Not a bad deal, huh? Yep. All right. There we go. See, that's what we'll put. We'll put that up there when you win. All right?
Okay.
So that brings us to our next thing, today's Math in the News. All right, that brings us to, well, we are getting close to the holidays, and Thanksgiving has passed, and we are in the middle of Hanukkah right now. Christmas is coming up, New Year's, all sorts of things are going on. So, have you ever heard of the song, The 12 Days of Christmas?
Yes.
You have. And do you know that song by heart?
No.
Give it another year or two, and you'll probably hear it enough times, and you'll know it by heart whether you want to or not. But anyway, so they talk about a lot of things that somebody would get during the 12 days of Christmas.
Yes.
But these things don't come free, right? You realize that everything costs money,
Yeah.
right?
Definitely.
So let's take a look at things. So if you were to buy everything, it would cost you over $40,000, which is a 5.7% increase from 2019. They're not using last year's prices because of the COVID and everything that was going on. So they're comparing it to 2019. So a partridge in a pear tree. And we have some lovely background music right there for us. So a partridge in a pear tree went up 6%, $222. It's kind of outrageous to me. Yeah, it is a lot, right? 2 turtle doves, right? 2 birds, right? $450. It's a lot of money. More birds, hens, $255, up 40%. That's insane, 40% increase.
I never realized how many types of birds are in this.
Oh, there are a lot. Now here we go, 4 calling birds, right? $600, right? A lot of birds. Not now. 5 gold rings, gold, right? You know gold is valuable, right? Well, there you go, almost $900 for 5 gold rings. 6 geese, another type of bird,
There you
right?
go.
We got some waterfowl here. 57% increase for 6 geese, right? 7 swans, hey, there you go, right? More birds, right? I told you a lot. Now this one coming up is interesting. 8 maids of milking. There's no growth in that. The minimum wage
Oh,
has not altered, so therefore it does not increase, right?
interesting.
Working woman right there, no increase, right? 0% increase, all right? 9 ladies dancing. Well, once again, okay, you're not looking at any increase in work here, okay? But 9 ladies, $7,000 that's gonna cost you. Well, you got
Wow.
9 of them though,
Yes.
all right? 10 lords of leaping. Well, it's gonna cost a little more than 9 people, so you've got $11,000 for that. 11 pipers piping. There you go. Musical performance, right? 12 drummers drumming, right? So you've got a lot of instruments and birds in this
Yes,
thing.
you do.
Right? So, George, I'd like you to select a year between 1984 and now. Any year you'd like.
1991.
Ooh,
1991.
Good year.
Let's go down to 1991 and see what happened with the index then. Well, you had an increase, $23,000, a 1.4% increase from the year previous if you wanted to buy all of those items. All right? Now, if we remember correctly, it went up to, I think it was $40-something thousand this year. Right? So 30 years later, right, you've got almost it's almost 100% increase between then and now. So out of all of those 12 things, is there one that strikes your fancy, one that you like the most or you'd like to see?
The 5 golden rings.
5 golden rings. Let's take a look at it. All right, 5 golden rings. So since 1984, we can see how it has gone up and down, right? Late 80s, 90, and then bam, goes way down. 2000 comes around, we get a little bit of an increase, and ever since 2008, 5 golden rings has gone up quite a bit. Right? So you can kind of track. And there are people that get paid to do math and take these numbers and statistics and do things like this with them. You think you'd like to do stuff like that all day?
No.
Nah, I don't know if I would either, but you know, the people do get paid to do this kind of stuff. So another one I want to show you is the 8 maids of milking. All right. So why do you think these are flat for a couple of years like that? Do you have any idea why you think, instead of it going up and down like some of the other ones, why do you think that's flat for a couple of years?
Maybe because it's, I don't know.
There could be a lot of reasons, right?
Yes.
Okay. But remember, when people go to work, there is a minimum wage. Okay. So if they go, you know what, everybody in the country must get paid $10 an hour. You must get paid $10 an hour for whatever you do. You can get paid more, but you must get at least $10. And we're going to do that for 5 years. And in 5 years, we'll move it up to $11 an hour. So it increases over a little bit of time. So does that look like something here maybe? Right? You get a certain amount of money and it's going to stay like that for a while, right? And then it will go up.
Goes up.
All right? So that's kind of the way I look at this and think about that, right? Anything else you want to look at before we get rid of this?
No.
All right, I'm done with it too, all right? Anyway, that is today's Math in the News, the 12 days of Christmas, and how much it costs for all of these assorted items. Over $40,000 to buy your loved one all of those 12 days of Christmas items.
Wow. No.
I'm not buying them either.
I
I'm
don't
not
think
even
so.
buying the 5 gold. I don't even want one
No,
gold ring.
no, I don't think I'm shopping.
All right, you ready to get to work, young man?
Yep.
Head to the board. You and Mary Lou are going to get started. I'm going to give you 2 fractions, and I want you to put them up there for me. All right? I want you to put, let's see, you're in 4th grade. How many children are in your family, your immediate family?
6.
There's 6?
Yes.
All right. So let's go 4 over 6. And next to that, don't put anything in between them. Leave a little space in between right now. And let's see. There's 1, 2, 3, 4. There's 5 of us in studio, so we're going to go 5 over 8. Okay. Now, would you like to compare those or add those?
Compare.
Okay, so you're going to do both. I just wanted to give you the choice of what you want to do first, all right? So you're going to compare them first, and then you're going to add them, all right? So explain to Mary Lou how you think you could compare these, and then when you're through, I want you to add them and see what you end up with.
All right, George, what's your first step?
I multiply the 6 times 5, then the 8 times 4.
Okay.
6 times 5 is 30. And 8 times 4 is 32. It's 32.
So let's so you're using that cross strategy, right, to compare. And we know another strategy is to turn them to the same denominator, right? So let's kind of rewrite those answers. So for 4 times 8, can you write the 32 above the 4 for me? And then the 6 times 5, can you write the 30 above the 5? So again, this is a strategy we kind of use to help us simplify, to see which fraction is greater, right? So using this strategy, which fraction then would you say is greater?
This one.
Why?
Because 32 is bigger.
Okay. Can you show me that with an inequality, the symbol? And a lot of times with the symbol, students get that confused, huh? What helps you remember that the symbol, the inequality goes that way?
The alligator mouth goes for the bigger one.
Oh, the alligator mouth. Yes, it's going to take the bigger bite, right? Okay, so that is a great representation of how to quickly get to our answer, right? It's a great strategy. Now we're going to add them. Okay. So let's go ahead and erase the 30 and the 32. And you can leave that there. Let's write it off here to the side. So we have 4/6 plus the 5/8. So George, what would you do first? What do we need to do first to help us with this?
Make the denominators the equal.
Equal. Okay, so what's your thinking? How are you going to make them equal?
I can't multiply 6 to something to make it 8, and I can't divide 8 divided by something equals 6, so I have to multiply them.
Okay, you could multiply these, right?
Yes.
We could go, whoa, 6 times 8, which is?
48.
48, you're correct. Or we could think, is there another number that's smaller that they both go into? Let's think. Let's start with our 6s. We know 6 times 2 is 12.
12.
Does 8 go into 12?
Yeah, no.
No. 6 times 3 is 18. Does 8 go into 18?
No.
No. 6 times 4 is 24.
4. And 8 times 3 is 24.
You got it.
So-
So let's go ahead and do this. We're going to pull this down. Hold on. Let's pull this down a little bit so we have room to write. So I'm going to rewrite this vertical like this. Is that okay? Have you seen
Yeah.
fractions this way?
No.
Okay, so what we're going to do is make equivalent fractions to help us add. And exactly what you said, you knew that 8 times 3 is 24, right? So on the denominators, can you give me 24? There you go. So you said 8 times 3 is 24, right?
Yes.
So that means we need to take 5 times,
3.
exactly.
And make it 15. Then 4 times 4
Right.
is 16.
Right, and we're not saying 4 times 3 because 6 times 3 is 18, right?
Yes.
We know that 6 times 4 is 24. So
Yeah.
what are you going to do with the numerators now?
We're gonna add them.
Okay,
The 24 is 16 plus 15 equals 31.
nicely done. So are we can leave it, this is one way, 31 over 24, right? But my question to you is, I noticed you just put 24 there. Why did you not add 24 plus 24? Because you're adding the numerators, why don't we add denominators? You were correct, this is correct. But do you know why? Because we have a common
Denominator.
denominator and we want to keep it that way, don't we?
Yes.
So we could leave it 31 over 24 or we could change it to
48.
a mixed number, right?
Yeah.
Do you know how to change that to a mixed number?
No.
Okay. 31 is larger than 24, right?
Yes.
So that means how many 24s go into 31? Just one, right?
Yes.
So we have one whole 24 that goes into 31, but what's the difference left over? What's 31 minus 24?
7.
Give me a numerator of 7 and give me a denominator of 24 because we want to keep our denominator the same. So both answers are correct.
Yes.
31 over 24 or 1 and 7 over 24. So here we have what's called an improper fraction, and that's called a mixed number. And they're actually the same answer. There you go, nicely done.
Yeah, I was going to say, so you've got quite a bit there. You've got yourself an improper fraction, right, where the numerator is larger, and then turning it into a mixed number. That's the first time you worked with a mixed number, correct?
Yes.
Okay, so you've got a little bit of an
Yeah.
introduction to that. You see the big open space down there at the bottom?
Right here.
Yeah, so what I want you to do is I want you to write the problem again. So over on the left-hand side, 4/6 and 5/8. Now, I gave you the opportunity to compare them because that's what you wanted to do first, right? And then we added them. What do you think I want you to do now?
Multiply them.
Not so fast there, young whippersnapper. We're going to subtract them, all right? So put a minus symbol in between there. So now, explain to Mary Lou what you think you want to do now.
Subtract the 4 by 5, which I can't do. So maybe I'll take 1 from here, turn that into a 5.
Oh, okay, I'm going to stop you real quick. Let's go back. Can you look back to how we added them? What was the first thing you did when we had to add the fractions? Before we could add them, because we knew that we couldn't add them this way, could we?
Yeah, so I multiplied the bottom.
Right. Did we have to change it to a common denominator?
Yes.
Can you use any of this information here?
Yes.
Yes. Do we already have what we need to set it up? What do you think? What is our problem going to look like then? What are we going to change 4/6 to?
24 16.
24/16.
16 24ths.
Perfect. Okay, underneath it, write that. Write your
16 24.
and then put our subtraction sign next to it, right? And what are we going to change the 5/8 to?
To 15 24ths.
Okay.
And then equals 1 24ths.
And our denominator stays the same, huh? So think about this, George. Sometimes we get problems where we already have done all the work, and can we look back at that work to help us with the next problem?
Yes.
Great job.
All right, nicely done. And we'll leave that up there because we're going to do some even more activities with those in a little bit. But you've done some great work so far, so you've got yourself a meal courtesy of our friends at Chick-fil-A. Yeah, there you go. I can tell you got a smile on your face. Who wouldn't have a smile on their face? Get some free Chick-fil-A right there. Old man, I tell you, I dig that stuff too. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. If you phone in today and next week, December 7th and 8th, and we do one of your math problems, you'll automatically receive a pass to Holiday Lights at Com. We'll be back with more right after this.
This week, Lab TV travels to NAVC Carderock in Bethesda, Maryland, to meet scientists and engineers who work with the heaviest materials, metals.
Metal usually comes out of the ground, and in an ore, it's an oxide or carbide, and you clean it up, and then you roast it and it becomes iron or copper or gold. Metal is an element.
Actually, most elements are metals. Metals lose their outermost electrons easily, and these form a negatively charged cloud around each atom. They all join together as a sea of electrons and pull on the surrounding positively charged atoms. This creates a strong metallic bond, makes metal shiny, and gives it some very useful properties.
It has what we call conductivity. So that means that we have electrons that can move through the metal, and it's due to this electron cloud that allows this passage of electrons. Metal can also transfer heat.
And it transfers heat really well. Metal has a high melting point and can be molded, stretched, bent, and pounded into all sorts of shapes.
A metal can be a series of elements on a periodic table, right? And within these elements, you can combine different metals to form what we call an alloy.
To iron, you add a pinch of chromium, you add a pinch of nickel, and there comes stainless steel. Doesn't rust. Before that, everything rusted.
Creating alloys improves the performance of metals. And to improve them even more, these scientists have developed a new way to combine metals called a metal matrix composite.
Now this is bronze here, the shiny material, and we added tungsten carbide. Tungsten carbide is an abrasive, and it will give you much better wear resistance. This is about 7 times as heavy as water, and tungsten carbide is 15 times heavy as water. So just like the sand sinks in water, here is tungsten carbide that sank in the molten bronze and gave it this particular property.
They can also create these composites by spinning.
When you pour silicon carbide, which is heavier than aluminum, in aluminum, and then pour it in a mold that is rotating, the silicon carbide being heavier goes to the outside, and it is all located here, while this is pure aluminum.
These composites combine the best qualities of each metal, and they don't wear out.
In fact, we are proud to say it will last forever, and the ship will go in mothballs, but this thing will not wear.
The Navy also has a great way to join pieces of metal, called friction stir welding.
This is a friction stir welding system, okay, and it's designed for joining and processing metals.
If you can imagine, you rub your hands together, right? And as you rub your hands together, you can feel how warm your hands get, like on a cold day. Sort of the same concept. You're rubbing two things together, you're going to generate frictional heat.
Well, it actually does it by stirring. It's like stirring cake batter. Your big mixer goes in there and just spins it all around, and that's what it does. It softens the metal, and then the tools start to spin, and it'll pull the material around the tool as it's going down the part and stick the two together without adding any filler materials.
Conventional welding can distort the metal. You have to add filler material, and you have to wear lots of protective gear.
With friction stir, you have none of that. No fumes, nothing. You just plunge that tool in, spin it around, whatever you need it to be welded, join the two together, and you're finished.
Metals will always be around. If you have a ship, you can't make it out of plastic. If something hits it, it will rupture it. But steel will bend and give and yet perform.
Because it's the strongest stuff around. That's the way I look at it. Because, you think about it, all your machinery, your planes, cars, bicycles, is all made out of some sort of metal. And that's just awesome to me.
To find out more about the structure and properties of metal, check out labtvonline.org.
And metals are awesome. All types of metals and things they were doing right there. Anyway, we do have phone tutors available until 5:30. We are celebrating our 20th season here on Do the Math, and one of our great partners for many years has been Science for Current. All right, here we go. Science for Current back in studio. Jamie, how are you this afternoon?
Doing well. How are you?
I'm excellent myself. Thank you for being here. So you've got George, a 4th grade student. What will you be working on today?
So today we're going to be doing an engineer design. We're going to look at dolphins and toys, and then we're going to work together and figure out how we can get this guy to swim. All right? So when we first get started, I want to show everybody this book. This is called Winter's Tale, and Winter was a dolphin who ended up having his tail amputated when he was two months old. And he was able to live successfully for 16 years. He just passed in November, but he was able to help engineering and prosthetics go a really long way. And there's even some really cool engineering prosthetics named after him. And so we are looking at going over biomedical engineering. So if you're really interested in that career, they look at prosthetics for animals and humans. So what we're going to do, George, is we're going to look at a dolphin just similar to Winter, and we're going to see how we can engineer a new tail just like they did for Winter. Okay? So we want to get a chance to look at a regular dolphin. So this is a wind-up toy. And what we want to do is we want to look at the structure. So when we look at the tail and we turn the tail, so I'll turn on the tail, what do you notice about the tail?
It's long.
Okay, it's long.
Yes.
What about its movement? What does it look like? Or can you describe the movement when it moves?
It flops.
Okay, so it kind of has like that up and down motion,
Yes.
right? So if I had a different animal and they had like maybe a turtle and they had the little arms, they would go more
Push.
right side to side. So we know that the dolphin goes up and down.
Up and down.
So what I want you to do is I want you to turn that, and we're going to put him in the water, and we're going to look at what it looks like when it's in the water, okay? And I want you to kind of come on over here and look at the motion that it makes when it's in the water. What did you notice about its tail?
It moves up and down.
It moved up and down. And then we can notice on this one, he goes a little bit slow, Okay, and it
Yes.
could be due to the toy. But we definitely see it can move, right? So let's see if we can create, because look at this guy.
Better tail for it.
Right. So it's just kind of like very similar to what had happened to Winter. Okay, this tail got
Yes.
caught and it broke off. So what we're going to do is we're going to look at how we can add a tail
Tail.
piece to it so we can successfully swim. So let's wind up that one, put it in the water, and see what happens without that tail.
He drowns.
Okay. Would you notice a difference between the one with the tail versus the one without the tail?
The one without the tail slowly drowns, and that moves more
Okay.
a longer distance.
Okay, that's what I want to know is, did it even move? Did it go anywhere?
Barely.
Barely went anywhere, right? And now poor Winter had to wait 18 months in order to get a prosthetic tail. It took engineers that long because it's really important to find out, will the pieces that they put on for the prosthetic, will it injure the animal? So we have to really, as an engineer, think about the animal, think about humans, and what we're using. So what we're going to use, since this is toys today, we're going to use plastic. So all I did was I cut the bottom of a plastic. If you had the lid, you can use the lid. And we're going to use these plastic pieces, all right? But before we do that, I want to go over the engineering design process with you really quick. So our first piece is we're defining a problem. What's our problem today?
Its tail got cut off.
Right. So we're going to
Build a prosthetic one.
Right. So we need to investigate criteria and constraints. And what that means is, what am I going to give you for your constraints? So what pieces am I giving
A
you?
piece of plastic from
Piece
the
of plastic, and then we do need a glue gun, but I will take care of that, okay? So we also want to make sure that in our criteria and our constraints that it's safe for the animal, okay? So our next thing we need to do is we need to brainstorm. Okay, we have to think about which type of shape do I want to have for my dolphin. So what I'm going to have you do before we start building that is I want you to kind of draw out what you think your tail will look like. What do you want it to look like? All right,
Like
that's a
that
great
kind of-
drawing. So can you explain a little bit about your drawing?
It has the tail like that, and so it can flop and go a longer distance than the one without the tail.
Okay. Now, engineers in their criteria and constraints, they were having problems with the brainstorming piece because dolphins like to jump out of the water, and sometimes that prosthetic doesn't get to stay on. So as they build, they have to adjust those pieces. So we start off with our first pieces in engineer, but sometimes we end up changing them over and over and over again. So that's going to happen as you go through the process. So let's go to the next one. Well, we could create a whole bunch of different types of tails, and then we can select one of those. So let's go to the next one. Let's go ahead and
Build
build.
a model.
Right. So you have plastic pieces, and you have some scissors. And what we want to do is we want to create two pieces, because when we glue them on, we're going to glue one on the bottom and one on the top. Okay? So what I want you to do, go ahead and start cutting out what your tail is going to look like. And if you're interested in doing this at home, all we did was buy toys that have the wind up, and then we had somebody cut those pieces off in order to have our broken tail, or injured tail, not broken tail. How we doing? Oh, that looks pretty good. All right. So we got that one piece. So are we going to put it on this way?
Yes.
All right. So let's see if we can cut another piece just like it. Can you do that?
Yes.
So as you're doing modeling in your cutting your pieces. We definitely can try different animals. They have not only dolphins, they have turtles, they have alligators. So you can try different animals if you wanted to on your engineering design piece. And make sure students have a really good set of scissors. You got it? Yep. There we go. And then today we won't have time to get to our next piece where we could actually, we will test it out, but we won't be able to improve our designs and then have a gallery walk around the classroom and see everybody else's prosthetics and then try and talk about a solution to our engineer pieces. All right, you got it? Almost done. There we go. All right, so we got our 2 pieces. So let's go ahead and
About the same size.
we'll put one on top like that.
And one on the bottom.
So I'm gonna go ahead and add some glue right here. I'm gonna put this one on top. All right, I'm gonna flip it over.
This other piece.
There we go. So what do you think of your design?
It's better than having broken tail.
Yeah, you think so?
And it's not that good because it still needs like glue and stuff right here.
Okay, and see, and that goes
Make
into
it
this.
thinner like this one.
Right, and into your engineer piece where we start to improve the design. So
Yes.
we have to start off with a model as an engineer, and then we go through and go, how can I improve that design? And you already know what you want to do, right?
Yes.
Right. All right, so I want to make sure that this is a little drier. All right, we ready to try it out?
Yes.
All right, so as an engineer, we got to try it out, whether it fails or whether we have success. We're going to try it out, okay? So go ahead and try it.
Oh, it's
So what do you think?
I mean, it went more length than the original one without the tail.
Uh-huh,
It went to the end of the bucket when it started right there.
okay.
And it's better than having the broken tail.
Right, so let's try this. Let's show our viewers at home yours versus the one without the tail. So go ahead and we'll turn them at the same time and then we'll put them in there to see the difference between them. Are you ready? So we have success, right?
Yes.
Good job. All right, so now let's compare it to the tail with the tail on it. The original one versus yours. We ready? Let's see the difference between those two. I think yours is moving a little bit more. Did you notice that? Watch. You covered a good distance. Wow.
Yes.
All right, so now, as an engineer, and we already discussed this, how do I change this to make it better?
We can put more glue right here and make it thinner, like this one.
Okay, so what I
So-
do is just kind of put those down and put the
Yes.
glue on? Okay.
Yeah.
What did you think about the tail design?
It needs more improvement. It needs to be smaller and like less thick. Like this one, it needs to be more round and
Do you want to try just one piece instead of the 2 pieces?
okay.
All right, so let's try that really quick. So I'm gonna go ahead and cut that out for you real quick. All right, I'm gonna make almost like a U shape like you did.
Yeah.
And I'm gonna round off that end. So now I have a piece very similar to what you did. I'll dry that off. And I'm gonna go ahead and add that on right at the top. All right, so what do you see the difference between the two?
This one's more curved into the middle, but that one has 2 layers, which might make it go faster.
Yeah, so you see that there's different layers. Okay, so.
That one carries more weight, so this one might
Oh,
go
okay,
faster.
this one's gonna have more mass than this one, right?
Yes.
Okay, so let's try that one out. All right, so you ready to try both of them out and see the difference between the two? All right, so this is your first engineering design piece. That's your second one. Let's see what the difference is. What do you think?
The second one was better. It was faster. Might have been because what I said, it had less mass on it.
Okay.
And it's more curved. So, and that one's better.
Oh, okay, so you like this design
Yes.
more than this one?
It's faster than the other one.
Okay, yeah, it was. Did you notice this one kind of started to go in a circle?
Yes.
Yeah, compared to this one.
Yeah.
Yeah. All right, so then now we think about, as an engineer, we got to go back to, we want to improve on this design. What could you do to improve on that design?
I can make it smaller, so it'll be faster, and nothing more.
You don't think so? And then
No.
nothing else? Okay, that's kind of cool though, right?
Yes.
All right, so what we didn't do is we didn't compare it to the original one. So let's do that. Let's compare those. Okay, we ready? So what do you think?
The original went the same speed as the one that's improved, but the original made it to a longer length.
So it went further than the other one?
Yes.
Oh, okay. But it didn't do pretty bad, huh? It did.
Yeah.
I think it did really well. Was this something you'd like to try at home? Like with different
Yes.
stuff? You can try different materials too, so we can always change those constraints and see if there's anything else. Maybe there's something even lighter than this, because you were talking about the mass, right?
Yes.
Right. So with Winter, Winter was able, with all the prosthetics they made, they went and they helped humans and animals with prosthetics. And some kids who only had one leg, they heard about Winter's story and then they wanted to get prosthetics too, just like Winter did too. So what do you think about this project?
It was cool and fun.
Mm-hmm.
It was fun testing them. Yes. And
You were successful.
Yes.
You're an engineer now. Good job. All right. Well, we here we created new tails for our dolphins from our original piece. And George here was successful in his engineering piece, and he was able to get our dolphins to swim, and they survived. So good job.
There we go. So
All
Jamie,
right.
if somebody wanted to know a little bit more about Science for Current, where would they need to go to?
So Science for Current has free science lessons for teachers, and you can go to www.scienceforcurrent.org.
All right, thank you very much. A great project right there, and I hope you enjoy your break.
All
And
right,
once
you
again,
too.
thank you to Science for Current for being part of Do the Math for many years as we celebrate our 20th season this year. We'll be back with more right after this.
Everyone begins as a scientist. You are already a scientist.
From the moment you ask a question, what, why, how,
What if? Why not?
how far?
From the moment you explore by experiment, build by imagination, you are already a scientist.
Science is a way of thinking.
Everything is made of star stuff. The universe lives inside of you.
Science explores living oceans, land like a fairy tale,
Prehistoric giants and artificial intelligence, diseases and cures,
Science is the study of everything about our world
other worlds.
and what makes us, us.
Science serves humanity.
Science seeks truth.
questions the rules.
Is it possible to see something that is impossible to see?
She helped discover that it is.
Keep asking questions.
Pursuing answers.
We need more scientists.
We need you.
Everyone begins as a scientist.
You're already a scientist.
What will you ask?
What will you answer?
What will be your adventure?
In my lab, we work on designing and fabricating novel materials and structures. Large number of mathematicians and computer scientists, engineers are working on origami nowadays. So imagine that you are going to use this origami structure as impact protection layer. And you are applying, let's say, hammer impact on one side.
The compression wave will eventually change into a decompression wave while it's moving through this chain.
So this video clip shows at the beginning of the impact, we have this red color formed due to the compression, but immediately after that, we have blue color due to the bouncing back motion of origami unit cell. But what is interesting is, at a certain point, we see blue color ahead of red color. What you are going to feel on the other side of structure is that rebouncing motion first instead of the compressive force. So what you're going to feel on the other side is more like pulling motion instead of compressive motion. The application can be abundant. For example, delivering a package using a drone. You want to protect your medium from the impact from the ground. And another example can be landing structure
And touchdown.
We can convert compression to tension so your whole structure can be well protected against the impact.
He said,
When I have visitors from outside and they look at these variety of origami, they are just amazed to see how this interesting origami can be integrated into state-of-the-art research. When we were starting this project, the mechanism seems so counterintuitive. So we were so excited, so thrilled, because we were not even sure this can really happen.
Amazing things happening all the time. Have you ever seen anything like that before, George?
No.
You think you'd like to work on things like that?
Yes.
That would be pretty cool, right?
Yeah.
So you did a little science there, you could do a little science there. Guess what else you need to do that stuff?
Math.
Hey,
Math.
there you go, a little math to go along with all that. Right? You do need a little bit of math. Hey, we do have phone tutors available until 5:30. Right now, we'll go to the phones. And Lucas, how are you this afternoon? Hello, Lucas. Are you still there? All right, so we may have dropped Lucas right there. I do believe he was working on a multiplication problem. And Mary Lou, let's go ahead and put the multiplication up there. I think I remember what the numbers were. We'll have the phone call paper brought out, but I think it was 670 times 42. Let me just make sure quick. Oh,
Okay.
hold on. 640.
640?
Yep.
Okay.
So 640 times 700.
Times 700?
I was close.
All right.
All right. So this is for Lucas, a 5th grade student from Valley Oaks.
Okay, so Lucas, what we're doing is we're doing 640 multiplied by 700. Right, George? You want to jump in with me on this one? So what would be the first step you would do?
I'd
give you that.
multiply 0 times 0, which
Okay.
is 0, and then the 4 times 0, which is 0, and I'll put a
Okay.
placeholder right there.
But do we, because we're staying on the same, okay, because this is the tens position, don't we need to move this 0 up?
Now
With
he
that?
might, so he might actually be fine with what he's doing, I
Okay,
think.
okay.
Let's let him keep going and
Okay,
see where
keep
this ends
going.
up.
Okay, then 6 times 7 is 42.
Oh, I see where you're going.
You see what I'm saying?
Gotcha.
He's just moving it in his head and
Yep.
doing it that way. So that's why I'm saying
Okay.
it looks like he's got it on track here.
0, 0 plus 2, and 4.
Okay, now let's look at this
Off
for a
1 0
second.
though.
Yeah, let's think about it. Should we be ending up with a smaller number?
No.
Okay, so where?
So it'd be 1,000.
Okay, so where do we need to add? Where is the 0 missing?
Right here.
Okay, so does that mean our numbers need to align a little bit better?
So, can I just?
Yeah, you can pull it over. Pull it over. There you go.
Okay.
Pull over a little bit more. Let's do that.
Okay. And I can make right there. That's 4,200.
Okay. So again, you did the ones first, right?
Yes.
You were multiplying the ones, and then you decided to multiply the tens, and then
the hundreds.
And then we multiplied the hundreds. Okay. So there we go. 4,200, and that is for Lucas, correct?
But let's hold on there, you guys.
Yeah.
That's 600 times 700. We've still got 40 in there we need to deal
We
with.
do. We have that 40. So let's look at it this way, okay? We have it, and I'm gonna do this. Have you seen the arrays before?
Yes.
Okay, so you guys have used the arrays, right?
Yes.
Okay, so I'm trying to think here how we can break this up. We have our work 600 plus our 40, yes?
Yes.
And then we're gonna have our 700 right here?
Yes.
Yes? Is that okay? So let's think about this. First of all, what's 700 times 600?
It's 42,000.
Yeah. 1, 2. Is it 42,000? Yes?
42,000. Yes.
How many zeros do we have? 1, 2, 3, 4. So would it be
420,000.
420,000. And now we have, let's think about this, now we have 700 times 40, right? So what's 7 times 4?
7 times 4 is 28, so we'll add 3 zeros.
Oh, yeah.
2,800.
Okay,
I mean
2,800.
28,000.
Now are we going to be adding these together?
Yes.
Can you do that right there for me? Can you add those two together?
And
28. So the 2 should go underneath the 2. There you go. 28.
8,000. The 0 plus 0, 0, 0, 8, 4, and 4.
There you go. So do you see the difference from here to here?
Yes.
Because yes, your thinking was was right starting out, but we were missing a piece, weren't we?
Yes.
Yeah. So again, if we kind of organize our thinking and break it up, this is just another way. Besides this, going by your place value, this is just another way to solve it.
And what I'd like you guys to do is let's do something else here because we want to get rid of that stuff in the middle right there.
Okay.
So do me a favor and erase that.
Yeah.
So that's not going to help us.
Let's do this. So we know 0. I'm going to show another way.
And
okay?
I don't even want you to go through all the 0 stuff.
Okay. So we're
Here's
just
what I
going
want
to
you to do. Do 64 times 7 and add 3 zeros.
Got it.
Show them that.
Ready? So what's 7 times 4?
28.
28. What's 7 times 6?
42.
Plus another 2.
44.
How many zeros do we have here?
3.
Did we get the same answer?
Yes.
There you go. So a lot of times we don't have to waste our time when we have zeros. We can just go ahead and multiply the numbers we see and then incorporate those zeros at the end.
Right. And there is a very popular algorithm where you can do that with all of the zeros. But then once again, as we saw, you need to make sure everything is lined up correctly with all of the zeros as you're going over every place.
Yes.
All right. But anyway, Lucas, hopefully that helps you out. There's a couple of different ways to solve that problem. And for calling in, even though we kind of had a little glitch with the phone, you've got yourself a pass to Holiday Lights at Com. So congratulations on that. Hope you and your family or whoever you decide to bring I don't think Luca's old enough to drive, so he'll be a passenger. Anyway, you ready to do some more work?
Yes.
All right, let's go back to the problem that we were working on.
Okay.
I think we had 4, 6, and 5/8, Marylou, is that what we were working on
We
before?
did.
So that is your problem of the day. Those are your numbers. Now, we compared them, we added them, we subtracted them. Now we're going to get into a discussion of multiplication, but we're not going to just multiply those numbers right there. We're going to do something a little different. And Marylou, I'm going to give you about 2.5 minutes
Okay.
to do this, about 2 minutes.
So before we can start multiplying fractions, let's think about what multiplying fractions really looks like, okay? So let's go ahead and look at this. Let's say we have 3 multiplied by 1/2, okay? Remember, multiplication means groups of, correct?
Yes.
So I have 3 groups of
Halves.
1/2, exactly. So if we did a number line, okay, and if that is 0, and then this is 1/2, and then this is 1 whole, and then we have another 1/2, and then
1 whole
this is
and
another
another
whole.
1/2.
So if I have 3 groups of 1/2, can you show me starting at 0 my 3 1/2s?
This is 1/2, this is 1/2, and
Okay, but if this is 1/2, right?
yes.
So if we have 1/2 from 0 to here, that's a 1/2, right?
Yes.
But what about from a 1/2 to 1?
That's a 1/2.
Is that another 1/2?
Yes.
And then from 1 to another 1/2, right?
Yes.
Do I
And
have my 3 groups of 1/2?
Yes.
Because here's a 1/2, right? Here's a 1/2, and then here's another 1/2. So
And
where did
this
I
is
end up
another
at?
1/2 also.
But we only need 3.
Yes.
So do I have my 1, 2, 3
Yes.
groups of 1/2? Where did I end up here? This would be 1 and
A 1/2.
a 1/2. So we know that if we're saying 3 multiplied by a 1/2, we're saying 3 groups of
Halves.
a 1/2, which gives me 1
1
and
and
1/2. That's looking at that as at a number line, right?
Yes.
We can also think of it as a picture. So if I have here, if I have 2 objects, say 2 candy bars, and I cut them in half, and I want 3 halves, I have 1/2, another 1/2, and another
Another
1/2.
1/2.
How
And
many?
It's 1 candy bar and a 1/2.
Exactly. So I have 3 groups of 1/2, right?
Yes.
So I've eaten 1.5 candy bars.
Yes.
So that's multiplying. But if we look at this same problem, okay, how can we quickly solve that with just multiplication and not do a picture? What are we noticing to get our answer? How do you write a whole number as a fraction? Do you know, George?
You can do like 4/4 or 1.
Is it, well, 4 over 4 equals 1. But how do I make 3 a fraction? What do I need to put underneath that 3?
3/3.
Well, that would be 1. I want it to equal 3.
And we'll put that
So-
over 1, and
Yes.
that's going to be something for George maybe to call in next week, so that way you can win yourself some holiday lights. But did you learn a little something?
Yes.
Good. Did you have fun today?
Yes.
Even more important. Yeah, you said, yeah, I did. Hey, you know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.